Kia ora, Year 11 and 12. Here is a question on a quadratic equation that comes from an old Cambridge exam paper, and it's from a Core 1 paper. Okay, but I really like it because it goes over a couple of big ideas that often come up at excellence level. The first one is the idea of the discriminant, and the second one is solving quadratic inequalities. Okay, so have a go at it first. Make sure you show some clear setting out. So this quadratic has got real roots. Now, just when we say real roots in a question like this, it means either it's got 1 or 2, right? So don't get hung up on the fact that roots is plural. What it means is it's not a quadratic in which there are no roots. It's a little bit ambiguous, and hopefully the level 2 exam setters in New Zealand would make it a little bit clearer. Okay, so then we're asked to show this. As soon as you read the question, you should be thinking it's a discriminant problem, and I'm going to need to figure out values of the discriminant. Then we're asked to factorise that and then to solve an inequation. Alright, so let's just start by writing out again what we've got. So we've got a nice clean quadratic already in the right order and equaling 0. So here we've got a equals 2k minus 3, b equals 2, and c is equal to k minus 1. So we need to make a statement that goes something like this. Probably easiest just to use the pen. For real roots, what do we need? Well, we need b squared minus 4ac is greater than or equal to 0. And that's assuming 1 or 2 of them. Okay, so we're going to now substitute in these values and work out b squared minus 4ac. So that's going to be 4, 2 squared, minus 4 times 2k minus 3 times k minus 1. And we want that to be greater than or equal to 0. So we get 4 minus 4 times this. Now we just need to clean that up. So 4 minus 8k squared. Now this bit here is minus 5k. So multiplied by negative 4, it's going to give me plus 20k. If you need to do that in 2 lines, that's vastly preferable to just getting it wrong. And then we've got minus 12. One last bit of collecting up like terms, we just need to clean up the constant. And we're going to write it now in the standard order. So negative 8k squared plus 20k, 4 minus 12 gives me negative 8. Alright, now because you hate inequations so much, I'm going to do the dividing through bit slowly. So first I'm going to divide left and right hand side by just the common factor of 4. Okay, so dividing through by 4, I'm going to get negative 2k squared plus 5k minus 2. Right, now if you look back at the question, we are getting closer to what we want, but we need to have that as 2k squared. So the next thing to do is to divide both sides through by negative 1. Now, most of you, especially when you're getting closer to the exam, should be getting fine with just doing that all in one hit. Right, so we're looking for the common factor in here, and we don't want to end up with a negative here. So I'm going to do that on a new slide. Remember, when I divide or multiply by a negative, that's when I have to reverse the sign of the inequation. Okay, so this becomes now 2k squared minus 5k plus 2 is less than 0, less than or equal to 0, and that was the first thing that we needed to show as required. So that was the first part done. Right, and the next thing we're asked to do is to factorise 2k squared minus 5k plus 2. This one we're going to do by inspection because that's a prime and that's a prime. So this has got to be a 2k and a k, and this has got to be a minus pattern, and it must be a 2 and a 1. So just by looking, I'm going to plonk the 2 there and the 1 there. Now let's just check that that works. We get 2k squared minus 1k minus 4k, so that's nice, plus 2. So that's that part done. Right, now I'm then told, hence or otherwise, solve this quadratic inequality. So we've done some of these in class, but they still need a bit of thinking. So I've factorised, and the factorising gives me my critical values. So that's step 1. So they're not solutions, but they are switch points. So the critical values are when 2k minus 1 equals 0 and k minus 2 equals 0. K is equal to 1/2 or k is equal to 2. The next thing I'm going to do is to draw in a number line, and those 2 points are going to be on it. Now let's take a look at what happens to each of those factors. Right, well, when I put in a value in the middle, well, no, we'll come back to in the middle. We'll put in a high value. Let's put in a value up here. What do we get? Well, 2k minus 1 is going to be positive, right? And k minus 2, if the number's bigger than 2, is also going to be positive. So this gives me a plus times a plus, right? 2 positives, which gives me a positive. Let's do this end next, and we're going to substitute in 0 because that's really easy. So thinking about it, this one will now be 0 minus 1, which is a negative, and here this will be 0 minus 2, which is a negative. So I've got 2 negatives multiplied together, so that also gives me a positive. And in the middle, if I substitute in 1, well, I'm going to have 2 minus 1, so 1 times negative 1, or a negative times a positive. So this is my negative region. So this area in here is going to be my solution set. On the next slide, I'm just going to write that out a little bit more cleanly so you can see what's going on. So we've got 2k minus 1 times k minus 2. We want to know when is it less than or equal to 0. And we did this little critical path thing, critical value thing, 1/2 and 2, and we found that in here we had a plus and a minus, which gives me a negative. So if I have k between 1/2 and 2, then that's the solution region for it. Now, it is really good to get in the habit of thinking about what the graph looks like for this, and we've got a factorised form, so I can pop on my critical values. There's 1 at 1/2 and there's 1 at 2. It's a parabola. I know the vertex will be halfway in between those two values, so at 1 1/4 I'm going to have a point down here. I also know that the intercept is going to be 2. Right, and you can do this on your graphics calculator. That's a really dodgily drawn parabola, but you get the idea. If you draw the parabola, you can easily check whether you've got it right. We're looking for values of k that will make this thing here be 0 or negative. And you can see on your graph that it's going to be this region in here. Okay, so that's all for now. If you want to do more questions like that, pages 64 to 66 in the Walker have got lots of great examples.